Thank you, Kathy. It's a tremendous honor to be here. I want to first start by saying thank you to all of you and to the Farmington Public School Foundation. I'm one of many teachers who is benefiting from the Foundation's work. It's a tremendous honor to be at a Board of Education meeting recently and to accept with one of my colleagues a $15,000 check, which we've already put to good use. And you'll be hearing from two of our students who have already used the 3D printer that we purchased with the grant money. When I first wrote a draft of this grant in the fall, I was looking for approximately $10,000 to put some equipment together in order to support several of our programs. And the foundation came back and said, based on your vision, we think you're actually aiming too low. And over successive drafts, the grant grew to a $95,000 commitment supporting 3 schools. So our goal with the grant is to give kids the opportunity to create their own designs and test and evaluate them. Prior to this grant, so much of the design work would stop with sketches, maybe a computer model, but now kids are actually doing the work. My 9th graders in my engineering design class are currently conducting a reverse engineering project. I challenge them to innovate the product, learn about it, take it apart, measure it, figure out how it works, and then change it. And they're actually about to 3D print the new parts that they've designed, reassemble the new product, and test it out in the coming weeks. The new next generation science standards include an engineering component. And this is very new for us, in that they want all students to be exposed to engineering through their regular science curriculum. And as you can see from this slide, we have 2nd graders doing design work. They designed a container with magnetic closure. And we have 4th graders developing their own questions and doing investigations with circuit design. At the middle school, we have students investigating the concepts of density and buoyancy. They've actually designed flotation devices for various action figures as they apply their knowledge. And in 8th grade, students learned about anatomy and applied their knowledge to develop hand models for specific tasks. In our middle school, in competing for the Science Olympiad, they designed a base instrument and they printed the bridge piece on the 3D printer and tested it out. And this year, our 9th graders at the high school, we were able to get a behind-the-scenes tour of Lake Compounce on the day when the park was closed. You see in the upper picture, if they were normally in that area, they would be quickly ejected from the park for a huge safety violation. But they came back really excited for a project-based unit in which they used their knowledge of forces in motion to design their own model of a coaster in the classroom, complete with a braking system. And we took them through the concepts of divergent thinking and brainstorming, and then selecting an approach in order to narrow down the possibilities and then actually test their design. This grant will also support our elective strands in the high school. We have a 4-year engineering sequence that starts with an engineering design class in 9th grade. It goes on to robotics and electronics. And the students that I will be introducing you to have taken all 4 of these courses leading up to a 12th grade capstone course, in which they're designing a solution to a problem that they have selected that is original. It will also support our Electrothon car competition team. This group designs, models, builds, and goes up to a racetrack up at Lime Rock Park twice a year. And they're especially looking forward to some of the additional equipment provided by the grant, which will include a CNC milling machine. And our US First Robotics team is actually competing this weekend at Southington High School. They go through a rigorous, intense 6-week build season to get a robot tested and functioning. And they're also going to be using some of the new equipment. Now I'd like to introduce two of our seniors. We have Antonia Washburn and Evelyn Pantelakos.
I'm Evelyn. And I'm Antonia. And well, just to start, I'm gonna tell you about what we really do in our capstone. So we go through steps that regular engineers do. We find problems and we think of an innovation and make a prototype. Something that me and Antonia, as well as our other partner Alicia, really agreed on was there was a problem with tangling headphones. So we decided to innovate a phone case to be able to hold
your headphones in a tangled mess in the case. We've also been able to make those on the 3D printer as well, because one of the problems that we came up with when we initially started this project was we noticed that, well, there's like all these great devices, like a tape measure mechanism that would retract the headphones, but nobody's going to want to carry around a phone case that's like this thick, because that's just bulky. So what we had to do is we had to go through a lot of redesign work and take it apart and look at, well, what can we slim down, what can we cut off, what's necessary, and what do we absolutely need to make it work. And as you can see, our parts are the white ones versus the black one, which was what we bought online to take apart and reverse engineer. And we've actually been able to get the phone case down to the size of about a normal OtterBox. And that's including the entire spring mechanism retracting inside of it. So we're currently at the point where we're working with an outside spring company to develop a spring that would actually allow them to retract. But thanks to the 3D printer, we've been able to develop new prototypes and make it so that the phone case actually fits the phone. All the buttons are accessible, you can take it out, the camera works, and we're really excited to see if it works. But all of this wouldn't have been possible unless we had the printer to try all that out and make constant adjustments.